Oh, yeah, I can hear you.
Yeah, no, I'm just interested in this. Sorry, I was having some tech issues. I'm just
Oh,
interested
okay,
in
that's
this, so
cool.
that's why I joined. I'm not in programming, I'm in finance.
Okay, that's awesome. Yeah, I made this particularly targeted towards non-techies. So I think you're going to find a lot of information that I give out in this pretty interesting.
Awesome.
Yeah, it's going to be pretty cool stuff, but simple to understand, and it'll be recorded. So in case you don't understand something, you could always go back or ask me questions, either during or afterwards. Hey, Vivek, I think I heard you come on.
Hello,
Hello? Hey, Vivek, how are you today?
I'm good. You?
I'm pretty good. So what industry are you coming from?
I'm a student currently at Mohawk College.
Oh, okay, cool. What are you
You?
studying?
I'm
I'm a
studying
programmer.
international business. Yeah, sorry.
Okay, that's pretty cool. Yeah, I'm a
Hey,
programmer.
dude.
Okay, okay, you're a programmer. Okay,
Yep.
what company are you working for currently?
Currently, I'm starting a programming boot camp. But before I used to
Okay,
work in insurance. I've worked in a lot of industries. I'll tell you about it in just a moment. So I've
Hey,
worked in.
Nilan.
no
This is
problem.
Vivek.
Thank you.
Hey, Rahul.
Hi, how are you doing today?
I'm pretty good.
Oh,
Um,
cool. So I'll tell about myself. So I just finished
okay.
mobile development from Georgian.
Oh,
I
mobile then.
Yeah,
Okay,
and
cool.
I used to work in cybersecurity analyst back in UK.
Oh, awesome.
I finished a master's in cybersecurity from University
Oh,
of London.
okay. Well, that's interesting. These cybersecurity degrees are relatively new, right? So what do they
Oh
teach you
yeah.
about? You'll probably know more than I'm going to
So
be covering.
yeah. So when I studied, we have two pathways. One is for the technical pathway, and another is for the business pathway. So I
Okay.
took the business pathway, which they taught me about ISO, like ISO 247,000, like all the
Mhm.
frameworks, like a PCI DSS, IPAR, GDPR. Then
Okay.
we have the cloud security. Then we have a cryptography. Then we have a secure business architecture. That was good.
Oh, that's pretty cool. Have you heard of the new program from the EC Council? So basically, they have this online university, and for each of the certifications, you have a class, and then you actually take the certifications. I thought that was pretty interesting as well.
Oh, is it? I didn't heard about that. But I used to see the Cyber and Pen Testing Academy. They have
Oh yeah,
good
for sure.
courses. Yeah,
Oh
Cyber
yeah.
has a good 70% off for the courses. That's
Oh,
good.
okay. So what do you think are the better certifications? I got my CEH, and I thought that
I
was pretty useful.
If you want to get into cyber security, I think CISP is the one people are looking for.
CISP.
Yeah,
Okay,
CISP and
but that's
uh,
higher level, isn't it?
yeah, it's a higher level. So if you're entry level, if you do CISP, I think that won't be any value for you.
Yeah, because you need 5 years of experience for it.
That's true.
Yeah, I'm more interested in the pen testing and stuff like that.
Yeah,
Um,
pen testing is really cool, but if you know what you're doing, then you'll end up in good place. But if you
mhm.
mess up with the little things, then you'll end up in the bad side. They'll think
Oh
you are
yeah,
an
you don't
hacker.
want.
Yeah,
Yeah, you don't want to get in. You don't want to get in trouble, right? But
true,
I think it's kind of
exactly.
cool to just know how everything works.
Yeah, that's true. Yeah, I tried a bit. It was good.
Oh yeah, oh that's cool. Have you used Kali?
I used a burp suite.
Burp Suite? Oh, okay,
Yeah.
cool. Yeah, Kali is include burps.
Okay, okay,
Burp
Kali,
is
Kali.
including Kali. That's
Yeah,
that's the operating system
yeah.
of
I
the
used
Linux.
in Windows. I used in
Oh,
Windows.
okay. Oh, okay, cool. Yeah, I'm thinking of doing like a particular class later on Kali Linux
Okay.
because it has
Oh
all
yeah.
that stuff already set up. It's pretty
Okay,
cool,
that's cool.
and it's so much easier now. Ever since it came out, because it automates a lot of the
Yeah.
system tests, so you can just run like a. I guess I won't go into it now, but it's
Okay,
really
we'll
cool.
do later.
Yeah,
Uh,
yeah. um, how about you, Mark? Where are you coming from? Could you hear me, Mark? I'm not sure if.
Yep. Just give
Hey,
me a
Mark.
sec.
Oh,
There. Is that working?
yep.
Cool.
What,
So,
what do you come? What field are you in, and what do you do? And
an escapee of 9 years of next and Apple technology.
oh, that's pretty cool. So you used to work for Apple and
Yeah.
Next.
And I did some
Wow.
work for Next before that. Yeah. And did a bunch of other contracting in the middle there for 15 years, ran my own company. And
Oh, that's awesome.
various things, predominantly web technologies, building computer-driven database solutions for customers.
That's awesome.
That generally, most of that was web objects. So building databases that went out to the web and
Did
build
you
websites dynamically.
You built them from scratch?
Yeah.
Oh wow! So
Yeah,
you
we
coded the
used-
actual databases.
I'm sorry?
Did you build the databases, or were you working with the databases? Like,
Well, kind of depended on whether the client had data.
Okay.
Generally, the clients had some idea of what they wanted to do, but WebObject's entire thing is taking data that existed only in databases and putting it onto websites. And before that, it did desktop apps. So in the 90s, I built desktop apps that were database driven. Built
Okay.
one of the first Unix to Unix distributed databases across UCP dial-up networks back in the day. Most, unless you're into Unix networking, most people these days have never even heard of those terms because that was antiquated compared to this whole, well, we just have our internet connection now. What are you talking about that you need a phone line?
okay, wow, that's actually really cool stuff.
Yeah,
Okay, so I guess we can get started.
Sure.
So this is Hacking 101, the net and monitoring traffic for non-techies. So I think you'll probably already know this since you're coming from a tech background. However, all the presentations here and more organized course lectures, video lectures, are available on the video channels. I'll be posting them in the chat as well as in the on the meetup group. I also just started a Facebook group recently because I found that I can't post a meetup at certain times. I guess it's high traffic. So you can actually visit the website, but when I try to update the information, it seems to error out. Okay, so a note to everyone, don't do bad things with what you learn, although you probably can. It isn't wrong to explore, but if you get on the wrong people's radar, they'll make your life a living hell. Stealing other people's information, monitoring, or doing anything that others wouldn't want you to do could put you in a bad position in the law if you are caught. And plus, don't do anything you wouldn't want done to yourself, to other people. Okay, so what is this meetup group about? Because you probably noticed that there are more meetups than just security. So the purpose of this group is to create a knowledge sharing and enhancement avenue for people interested in technology through hands-on exercises and tutorship in anything technical. This includes hardware, software, security, etc. Later on, I also want to provide an avenue for networking amongst professionals and companies. We'll have live meetups later on as the group grows and develops. If you would like to share information later on or give a presentation about any particular area you're knowledgeable about, I'll reach out and I'd be more than happy to set something up. And I'd be curious to learn what you guys know, because all of you seem to come from different backgrounds and different experiences. So to learn your particular niche would be interesting. So who am I? I finished a degree in computer engineering over 15 years ago. I've worked in everything from digital hardware design to databases and web application design, and I've seen things change over the years. I've worked in insurance, gaming, finance, healthcare, manufacturing, and hospitality for big and small companies. I've also worked with several frameworks and languages in a professional as well as academic setting, including VHDL, assembly, C, C#, Java, PHP, WordPress, .NET Core, web forms. And later on, I'll also be giving and building coursework for those things that I've worked with as well. I write storybooks as a hobby and enjoy working out. I'll post links to that in my thing. And they're available, the books I've written are available on Kindle for free. My current hobbies are weight training, traveling, movies, writing, and eating. So these are the books I've written so far, in case you're interested. So we've already introduced ourselves a bit prior to this lecture starting, and I think you all come from pretty interesting backgrounds. So story time. I came up with a little story to introduce you to this new world. There was a time not so long ago when a small group of mysterious people armed with little knowledge had the ability to live life outside the law. These misfits had access and knowledge to a world and infrastructure that remained a mystery to most. With the whisk of their hands, they could affect banks, control the power grids, make untraceable calls for free, or even erase their very existence. To the rest of the population, their existence was almost magical, and the words they used for it. They were a small group of rogue renegades and weirdos who managed to pull off magical feats that the average person thought impossible, with the click of a button or the crossing of a wire. The world didn't know what to call these people as they began to appear. These people's core drivers were not of a corrupt emotion, rather than curiosity of how things worked, and the urge to show off and outdo their friends, which each feat they would baffle and confound. Never since the time of Nikola Tesla, a scientific magician of his day, had the world been thrown into such awe. A single program with the ability to take down the internet, a single man breaking into 40 of the world's largest corporations. This was the world of the early internet, a simpler time when the internet's potential was still in question, and the number of people who knew what a hard drive was just a handful. These magical groups of people were given the names hackers and ushered in a new age of paranoia, imagination, and knowledge. The concept of hackers was popularized by the 1995 cult classic, Hackers, starring Angelina Jolie. But how did they pull off these feats? How was it possible? Knowledge of how things worked. The reality is, the internet and many large infrastructures were not built with the concept of security in mind. They were built to serve a purpose with the assumption that the people who used it would not have the knowledge to abuse it. This includes infrastructures like the power grid, telephone network, and more. Security on a lower level was afterthought and not considered to be of much importance. The way programs were interacted with over a network was often open and allowed for users to easily gain access and abuse the systems on a higher level. Breach after breach by malicious hackers, the importance of cybersecurity was brought to light. No company seemed immune. Microsoft, Apple, Yahoo, banks, insurance companies, nuclear plants were all hit and initially defenseless. So that was my little blurb. You guys probably watched Hackers. That was a great movie if you haven't watched it before. Here's some fun facts. The world's most famous hacker, Kevin Mitnick, was kept in solitary confinement for 8 months because law enforcement told the judge that he could somehow dial in to the NORAD modem via a payphone for prison and communicate with the modem by whistling to launch nuclear missiles. After getting fired in 1996, Timothy Lloyd, an 11-year employee of, forgot the name of the company, Omega, planted a hacking time bomb within the firm's computer system that deleted the firm's main operating system 2 weeks after his layoff, making the firm lose over $10 million and fire 80 employees. In 2007, a researcher from IBM was able to gain complete control of an American nuclear plant by hacking it over the internet. Those are some scary facts, even though I think that they exaggerated Kevin Mitnick's whistling ability, but still. So also a note, I'm giving you guys an distraction. There's more to it, but I'm leaving out the details that might cause confusion. I'll set up meetups later on for more complex concepts if people are showing interest. So to start off here, a couple of definitions I think need to be understood as we delve in a little bit deeper. The first definition is a network, which is a bunch of computers or devices connected together that communicate and share stuff like files, resources, etc. The internet, for example, is a giant network. Subnet. A subnet is basically a smaller network that connects to a larger network. Protocol is basically a language that applications use to communicate over a network. Packet, a grouping of data that applications send over a network to communicate. Think of it like the words in a language. So if a protocol is a language, the packet is the words in the language. So two applications in order to communicate would have to speak the same language, sort of like people. So a purely English speaker would not be able to speak with a purely Chinese speaker. You would need someone that spoke Chinese or English on the other side of the communication in order for the two people to communicate. And the same applies to protocols, application protocols, as well as packets. Okay, don't worry if you don't quite understand it. We'll be looking at it a little bit deeper in just a moment, and hopefully that'll clarify things. And this lecture will be available online afterwards. Client. So a client computer is a computer on a network that requires information, requests information or resources. And a server is the computer that gives other computers access to resources it has control over, like files, websites, etc. An IP address is a numeric or hexadecimal value used to identify each computer connected to a network. It is much like your home address, except it's used by computers to identify themselves over a network. A port is specific to each computer, and you can have many ports on the same computer. So if a computer has an address, which is called an IP address, each application service that communicates in a specific language uses a port to communicate in that language. This will also be made clear in just a moment. And machine address is a unique number assigned to a network device. So gateways, when a small network is connected to a larger network and data leaving that smaller network or coming into that smaller network will pass through a common device. This device contains the gateway. So think of it like a room with a single door. So anyone that comes into that room or leaves that room, if the people are information, has to leave through the same door. So that door would be considered the gateway. So for subnets, they would have a gateway in order to access larger networks. And routers or switches. These are basically devices that connect multiple computers together in a network. And and the router usually connects you to a larger network. So that would have the gateway in it. Okay, so this is a display of how the internet sort of is set up, what I'm showing on the screen. So the user, you would have multiple users in the network, and they would access the network through your modem. Oftentimes these days, switches, routers, and modems could actually be combined into one. So your computers would communicate with the modem in order to access the larger network, which is the internet. And then through a series of intermediary waypoints, you would be able to access the web server on the other end. There's more to it than that, but we'll save that for another lecture. So that is how the internet works. So from your client computer, you make a request for a website, and the web server, which holds the website, will send back to you that information. So let's take a moment to explore a few fun facts. In 1995, there were only 25,000 websites. Today, as of 2020, there are over 1.7 billion. In 1995, Newsweek released an article stating why the internet would fail, and you can still find it today. Like, I'll show it to you. I have it open in my browser. And so in 1995, this article was released by Clifford Stoll, and he was stating how the internet wouldn't work out. And he was wrong, because the internet is everywhere, just considering the growth. the internet has changed vastly since 1995, and you can see how websites have evolved over time by using this website called the Wayback Machine. So this is another cool little website that they have up, and the Internet Wayback Machine. You could just enter in the website of interest. I'll put in Yahoo, and it has snapshots of the website from different points in time. So let's go back to 2000 and take a snapshot. I'll take it from February 28th at 9 a.m. And it'll load up how the actual website looked on that day. And it has changed vastly if you look at it right now. It's pretty cool. The internet and underlying protocols are documented, and their inner workings are open for everyone to see. These are documented in things called RFCs, or requests for comments. And if you want to obtain detailed information and documentation of how the different components and protocols work, you could just type in Google, RFC space the number, and it'll come up. So let me show you that. RFC, this one. And the first RFC is shown on the IETF website. And if you click on it, it'll give you a detailed description of the different parts of it and how it works and how it's meant to work, etc. So if there's a particular protocol you're interested in learning more about, you can just type in the RFC and find it, and you'll be able to delve more into it. So I mentioned a lot about IP addresses and machine addresses before. If you want to find this on a Windows PC, you could use the command ipconfig/all in command prompt in Windows. And if you're on a Mac or a Unix machine, I believe the command's ifconfig, but you'll have to verify if that gives you more than the IP address, I believe. So let me show you. So I'll type in ipconfig/all. And as you can see, it lists all my network drivers. These are what my computer, network interfaces. This is what my computer uses to connect to a network. The devices that are not connected to a network will only have a physical address, also called the MAC address. And this is basically the unique identifier to specify all the devices, the network devices it's associated with them. However, the moment that it does connect to the internet or a network, suddenly an IP address is associated with it. As you can see, there's an IP version 6 as well as an IP version 4. There's an interesting story about this. Initially, there was only IP, they're basically, so the IP version 4 is a numeric number separated by dots. What happened is that as the internet grew exponentially, they realized they were running out of addresses in order to give to people that connected to the internet. So as a result, they released IP version 6, and this uses a numbering system called hexadecimal, separated by double quotes. And it allows for more address spaces on the internet so that more devices can connect to the internet at the same time. So that's the story behind changing the actual format of the IP address. So, and if you recall, just to reiterate, the IP address is the basically tells other computers where you are on the internet or a network. It's a unique identifier when you're connected to a network. Okay, so how it was before. In the beginning, before graphical operating systems, everything was command line. In order to connect to the internet, oftentimes you would log in to something called a BBS, or bulletin board service, via your phone line modem, and you would request that BBS connect you to the internet because it would provide a bunch of services to you. On these BBSs, you could communicate with other users that used it, share files, play games, and read news, and much more. So even though in the past you would connect to BBSs with a dial-up modem, there are existing BBSs that offer a glimpse into the past. So I could show you it. Okay, so I'll show you a BBS that's still up. And so initially in the beginnings, you would have to this is how you would connect to another computer. So something like this would come up. This is the intro screen for this particular BBS. You would enter in your username and password. And here's a welcome screen. And then once I was in, there would be numerous services. I could play games, I could talk to other people, I could access news groups, which would allow me to download files, and much, much more. So that's a glimpse into how things used to be. So through this, I would select to connect to the internet, and it would connect me. Different BBSs offer different services, but that's a blast from the past. Things have changed now. All you have to do is really have that modem up, right? Okay, so next. So protocols revisited. I mentioned protocols, and I mentioned that they're like a language, and they often use English characters, right? So let's take a look. So right now what we're gonna be doing is looking at packets on a network. We're gonna be utilizing something called Wireshark to obtain the passwords of someone entering information in an insecure form. We won't be covering monitoring secure lines at this meetup. There will be a separate meetup for that. So we're gonna be looking at the packets. Looking at the packets on the network is something called network sniffing. And if you understand what is going on, you could often obtain useful information from it. In particular, we're going to be looking at HTTP packets. These are the packets that websites are sent in, or the protocol that websites use. So if you notice, whenever I type in a website, there's a HTTPS:// and then the website address. So, okay, so this is the website we're going to capture the information of. So I'm going to open up Wireshark, and I'm going to start it up. And I'm going to select my Wi-Fi modem because that's what I'm connected to the internet with. I'm going to add in a filter to just show HTTPS packets. I'm going to go back to the browser. I'm going to change one thing on this page for simplicity's sake. And okay, so what we're going to do now is enter in our username and password and click login. And it says what the username and password was that I entered. And then it's going to submit this information, and I'm okay. And it submitted it. So what happened on the network, we can see by using Wireshark. So in Wireshark, the first window on top has things like the source IP, which is the address that the packet is originating from, the destination IP, which is the address that the packet is being sent to, the protocol that this packet's in, and as I mentioned, if packets are words, protocols are like the language that the packet sent in, as well as the information contained within the packet. The second window shows the details of that packet. So each line in the first window, I could select and get a more detailed view of what is contained within that packet. So if we were to go to the first packet and go to HTML form URL encoded, you can expand it and you'll be able to see the username and the password that I submitted over the network. And if you were monitoring someone else's computer and they were not using a secure form, you'd be able to capture this information quite easily as well. Even if they are using a secure form, these days you can still capture that information. But I'm not going to get into that right now because that's a little bit, the approach would be a little bit different. And we don't have enough time to get into that. But yeah, so if you're ever curious, and I encourage the use of this, you can look at what is being sent behind the scenes by your applications on your network by using Wireshark. And these are all the packets that are being sent, and they're different types on the background. These UDP packets are probably from the Zoom stream that I'm sending out right now. So now you know how to monitor what's going on in your network and see what other people are sending, because you could not only monitor your information that you're sending through your computer, but also the information that other people are sending from their computer. And you could use the filter in order to zoom in on their packets and see what they're sending out. Okay, so if you don't want this to happen to you, say you're at a coffee shop or somewhere else, and the router is open and it doesn't provide any, the modem is open that you're connecting to and doesn't provide any protection, you could use, the easiest approach would be to use VPN software. And you also understand why they say you shouldn't go to any sensitive sites while you're at a coffee shop, like your banking sites and stuff, because people could capture that information and use it without you being aware of it. Okay, so the next thing I wanted to revisit was email protocol, because usually with protocols, you're not going to be working with packets in most cases, right? Especially since you're just learning about it. But in order to clarify how things used to work and how everything used to be plain text or just words, I wanted to give you an example of the SMTP protocol, which is the Simple Mail Transfer Protocol. So whenever you send an email, it's sent using this protocol, and you use something called an email server in order to have it send out your emails. Authentication to this protocol and many other protocols really only came later on, not during the early days of the internet, but as it evolved and they realized that there were these openings for them to be abused. So for email, the servers had the ability to be open until 1999 when they added authentication to it. Prior to that, it was open. So we're going to send an email using Telnet. I have set up an application server on my computer, SMTP application server or email server. And what Telnet allows me to do is communicate with other applications on over a network using text. So that way we could see what applications do behind the scenes. Because as I mentioned before, in the beginning, everything was command line or done with plain text. So telnet localhost 25, enter. So what would happen is that I just connected to an SMTP server and it said 220, welcome. So it's acknowledging of me connecting. Next, I'm going to say hello example.com. So I'm basically telling them hi to tell them I'm here. So it responded, acknowledging that it knows I'm here. Next, I would specify the email I want to send it from. And you can specify any email here. And then I press enter. And then who I want to send it to. And I would specify I was sending it to my email address. And then I start the data. So this is the actual app. This is telling the email server I'm going to be entering in information that's in the body of the email. And then I specify the subject. As you can see, it confirmed that it received it. And presentation example. And then that's the subject header, or the header you see when you receive an email. Press enter. And then I'm going to type in the body. And then I would type in whatever I want in the body of my email. And then in order to end the email, I press period. And that's how it would be sent out. I blocked off the port to send outgoing emails on my computer with my firewall. But if I didn't, it would actually send it to my email. So this is in the email queue. And that's how easy it was. And this is how you would send out an email just using your computer. And you could actually use this even today if you wanted to set up your own sort of webmail UI. So you could make a website like Google, that has a list of emails, an email server, and you could send out the emails here by simply sending out, running telnet on the background if you wanted to, and communicating it like this. Why would that be useful? You could make a mass marketing program or something else. You could use it in a lot more ways than it was meant to be used if you actually desire to, by using it on a lower level. And that's the actual allure of using programs on a lower level rather than using it on a higher level. Because if you're using something like Gmail, your actual abilities might be restricted and you would have to do a lot of stuff manually. But having access to this functionality, you can code out a program and make it do a lot of more of the work for you without you having to do it. Okay, so let's discuss how it's changed. These days, people often enforce the utilization of usernames and passwords even at a lower level when utilizing or communicating with these application services. And they convert the communications into a secret language. Only the two computers communicating know through a method called cryptography. But we're not going to discuss that today. That's another lecture on its in and of itself. And firewalls are extensively used. This is basically another application using that restricts what ports can be used and what applications can run and communicate over networks. Because sometimes when you install an application, it's going to automatically try and gain access to a port. So you need, and it might be insecure. So the firewalls will prevent that vulnerability from exposing your computer, especially from savvy network users who abuse the vulnerable protocols. So yeah, that's it for the hacking, this introductory hacking class. And to say what we'll be covering in upcoming hacking classes, I was thinking of the following: the cybersecurity, hacking culture, and the dark web today. So a brief glance at all the things that are out today and how it's changed over time. Basic network hacks and how the networks could be abused and protected against. Introduction to software vulnerabilities / hacking hands-on labs and how to protect against them. Introduction to web application vulnerabilities, hacking hands-on, and how to protect against them as well. I guess that would be a little bit more advanced, the last two I mentioned. Introduction to gaining access to remote systems, hands-on, and building bots for different systems for programmers, as well as an introduction to viruses, Trojans, and antiviruses, the histories, the different types, how they work, and building a simple one, as well as protecting against it, and exploit meetups later on. So other stuff we do in this meetup group, and we've been having meetups for, is introduction to .NET Core MVC, introduction to web development. WordPress will be coming up, business intelligence. I mentioned how I used to be a database developer, but I was actually a business intelligence developer, which means you create reports, build out the databases, build out the ATL, as well as build out different types of databases. Introduction to programming for non-developers. And I'm also thinking of starting a web application bootcamp for people wanting to change fields into programming. It'll be free at first. I'm looking for 5 people. So just reach out to me if you're interested in learning about that stuff. And even if you're working, we could arrange times after work in order to get you up to speed in case you're looking for a transition into the programming field to build out web applications. Also, Roy Kim, an MVP of Microsoft, is giving a presentation the first week of February regarding Azure and the cloud, Microsoft Azure. And we'll also soon have hardware hacking. And a lot of these meetups will be live and in person later on. So yeah, that's it for now. Do you guys have any questions? If you are, feel free to unmute yourselves and talk. Show thumbnails. Any questions, guys? If not, I guess we'll call it. It went a little bit fast today. I expected it to go longer when I timed it, but I guess it didn't. Oh, do we only see networks on our computer? What do you mean?
So the Wireshark has access to what's on the network. Is it only whatever's connected to our computer, or anything connected to the system?
Well, it depends on the type of network. There are ways around it. So in order to monitor traffic that's other people's, coming from other people's computer, you got to put your modem in something called promiscuous mode. And then it'll pick up the packets from other people's computers, right? There are some routers and switches that defend against that by using individual VPNs in order to mask other people's traffic. So you won't actually see it, but you can get around that using something called ARP poisoning. But we won't delve into that this lecture. So basically, what you're doing in that case is pretending you're the gateway. So everyone that sends packets will send it through your computer, and you'll be able to see whatever they're sending.
Got it.
Any other questions? So for the people that joined, like later on, do you want to introduce yourselves? Because we had an introduction earlier on. So, for example, Zoo. So why don't you tell us who you are, what you do for work, what are some fun things you like to do, and something interesting or funny about yourself. Or you don't have to if you don't want to, though. Or Joan. Or I believe we met before, Paolo, but if you want to, you can introduce yourself to the group. You can unmute yourself.
Can you hear me?
Yep, I could hear you.
Oh, okay. So my name is Joan. I just recently graduated from a webmaster program, which is like, I mean, I am totally new to the field, and from that 4 months later, I guess I know something, but not enough. And something I like to do, I guess I like to sing and working and maybe coding right now. Something interesting about me.
Okay.
Yeah, not that I don't want to ask any questions, I just don't know where to begin to be everything for me.
Oh, okay, that's cool. If you have any questions or want to contact me or reach out later on,
Okay.
here is my, here I'll post my, the links as well as my email address. And there will be more meetups later on, as well as, so those are the links I showed in the presentation, and this will be posted online as well on the meetup group. Anyone else want to introduce themselves? If not, I guess we could call it. I hope you guys enjoyed that. So yeah, I guess that's it for now. I hope to see you around again. Thanks for coming. And we'll be having live meetups later on. Have a great day, rest of the day. See you later. No problem. No problem. I hope you guys learned something useful.